Howdy once again, and this is Toolmaker, and this is part 2 of the build on the Toolmaker's clamp. And this clamp is what we're building and is based on the Brown & Sharp 4-inch Toolmaker's clamp. And in the last video, and you need to go back and watch that if you haven't already seen it, I make the 2 screws. So that was about a 25-minute video in itself. So in this video I'm going to make the 2 parallel clamps itself, and the material again is 1/2 inch square mild steel. You can use tool steel if you want, and it's just a hair over 4 inches long, so I can trim it down to length. So let's get started. The first thing I like to do in preparing the stock is to just take some thinner and remove any oil or grease that may be on there from shipping to prevent the rusting. And this is probably pretty old oil that's been on there for 30 years, so off it comes. And you don't want to use your layout bluing or dye over oil, so off comes the oil. And then I like to take a sheet of emery cloth and get the table clean, and you can do this on your belt sander too, but I just like to take it and knock the burrs off. If you have any saw burrs, take them off with a file, but that just cleans up all 4 sides real quickly. The first thing I like to do is to square up just one end of both pieces, and that can be done on the milling machine, and it's set up like I'm showing you here, both at the same time, and just run the milling cutter right across them. But if you do not have a milling machine, there are several other ways to do it, and let's take a look at them. Another way is to use your belt sander. If you have a miter gauge that's capable of squaring them up, just run it over here like this. Saw marks off. Another excellent way of doing this is, and I don't use a 4-jaw chuck very often, so I have the work in a 4-jaw chuck, and I've centered it approximately. And don't bother to center it real well, because you're just wasting your time. You could be a 1/4 inch off and you're still going to square it up. It's just not that critical. So do it like this if you decide to. You see how much it's wobbling. So what? Tripod's a bit in the way here, that's why I'm so slow. The finish could absolutely not matter less on the ends, because that's all going to be reworked later on. But measuring from one of the finished ends, and I put bluing layout die, Dykem, on one of them. Lay it out any way you want, but this combination square is set for 4 inches, and you can see I've got about 1/8 of an inch to trim off here, and you only need to mark one of them because we're going to do them as a pair. Or if you're going to do it on the lathe like I just showed you, then you need to mark both of them. But I like to do them as a pair, and then they will be exactly identical in length. Work safely. Be sure and wear your glasses. Protect your eyes. They are the windows to your soul. So I'm at the Bridgeport now, and in order to set these up, I've got a 1-inch parallel there. Use whatever your vise needs, and I'm going to butt these together like this to get the ends the same. Hold them tightly, move them in, and we want just a little bit sticking out of the vise, and back that parallel off so you don't machine the parallel and ruin your cutter and your parallel. Tighten the vise, and I'm ready to mill right across, and you can see that my layout line is visible and easy for me to follow. But again, on a linear dimension like this, 4 inches, unless it's specified as a decimal, you know, you got quite a latitude here, so it doesn't really matter if it's a little bit over or under. Time to mill them down to the line. Now I just locked my table in the longitudinal, or the XY I should say. That's conventional milling. This is climb milling. Don't get your brush caught in there. I'm climb milling now, and I always like to take my last pass climb milling because it gives a little better finish, even though I told you that the finish doesn't matter on this. I take it right down to the line and a couple more passes. Now as I start the layout, the order of operations here and drilling and tapping and so on is pretty important. So try to follow this unless you are rather advanced. But if this is the first one that you've made, you might want to listen carefully to this or even replay it. But I'll do my layout just on one of the pieces, the top piece that I already have blued, and these have been again machined to length now and they're ready to go. So, and I already have die on one of them. So I'm going to lay out, if you look at this, the holes just in this piece, because we're going to drill through this piece and into the other one, and then everything will line up. Now some of you have a digital readout on your milling machine, and this can all be done on the milling machine if you have one and want to do it that way. I'm not going to show it that way. I'm going to lay it out in the traditional manner here on a surface plate, or you can do it with any tools that you have, and then I'm going to do that drilling on the drill press and just the tapping by hand. But you're free to do it any way you want. But I'm going to lay a center line out. This is 1/2 inch square, so I have my surface gauge, or my height gauge rather, set for 1/4 inch, 0.250, and you can use any method you want. Surface gauge is fine too, but I'm going to put a center line on there. Make sure that your plate is clean. Wipe it with your hands. Wipe the bottom lapped surface of your gauge. This is the way I do it. That's a carbide tip scriber. I like a nice deep line because my center punch can then find it. This first hole is 5/16 from the end. So I'll lay it out like this. I'm just going to use a combination square already set for 5/16. Mark it. My thumb's in the way. And you can do this with the height gauge or any other way you want. Use a nice sharp scriber. And then the next hole is 1 3/4 from the first hole, or if you add the two together you have 2 1/16. And this combination square is already set for 2 1/16 conveniently. And there's that line. Now I'm going to center pinch those very carefully, and I like to start by using my automatic center punch, because that, if you've ever used one, there's so many different ways of doing this. But you can literally, if you have a deep layout line, follow that line almost like a furrow if you have a sharp center punch. And if you click, you'll feel it come into the cross one, and then you can punch it. Do that to both of them. Now if you're doing this with a digital readout, directly drilling on the milling machine, there's no need to center punch, or for layout for that matter. I found it necessary to sharpen my center punch. It had been dropped, it fell off the bench, rolled off the bench. So now that it's sharp, I can feel that furrow that I just talked about. I'm in the furrow, click, and I feel it come into the other, and right on. I'll do the other one the same, and then I usually come back and center punch them again with a traditional prick punch or center punch like this. I don't like to pound on the granite plate, so I'll do that on the wood, so that it's a fairly deep center punch mark. Those need to be accurate. I think you can see how nice the center punch marks are. Now the step that I'm taking now is optional, but I love to do my initial drilling with the 1/16 inch bit on my micro drill here, my Cameron, I know you don't have one of those, so it can be done on another one, but the idea here is with a sharp bit that this can float around. I'm not using a vise, and the drill bit will truly go into the center punch mark. It will not drift off. And you just need to drill in a little ways, perhaps 1/8 of an inch or 1/16 of an inch. It doesn't have to be much. I'll do the other one. Now those holes will not drift when I drill them a larger size. Let's talk about these holes now. We've got a threaded hole here and here. This is a blind hole. I'll put a B there for blind, meaning it doesn't go all the way through. This is a clearance hole. This is where the order of operations here is pretty important. So what I'm going to do here first is just to drill this hole. I'll come back and do this other one later on, but I'm going to do this one now, and I'm going to drill it a pilot hole, perhaps 3/16 through both pieces. I'm going to clamp the pieces together. Then I will separate them and drill the clearance hole in this piece, and mark your pieces. That I think it'll really help you if you mark things so you don't miss drill. It's so discouraging if you drill into the wrong piece and have to start over. And if you do that, just quit for the day and go watch Andy Griffith reruns for the rest of the day, and then come back with a fresh mind and a good attitude the next day. I used a little clamp here, and I got the two clamped together, and I did that on the surface plate, and I butted these two ends together. So now they're clamped together. I'm going to leave that clamp on there while I drill. And I know what you're thinking. Why didn't he use a Toolmaker's clamp? It was a little bulky, so I wanted to use this. Now just a point here is that when you start to drill these, remember this hole is going to go, this is the one we're doing, it's going to go all the way through. So make sure you use a vise where you're going to straddle the hole and not drill little holes into your vise like some moron did on this one. This was a used vise. And when you hold this, unless you put a clamp on there, it's very likely that one of the pieces is being held and the other one is loose and will rattle around in there and move on you as the drill enters it. So take care that that doesn't happen. You can also use some packing in there, some paper or something that will help prevent that. But I'm going to, before I go over to the drill press, again, these threaded holes need to be drilled with a letter I, and that's looked up in any kind of threading chart. And that letter I is for 5/16 24, which is Unified National Fine. And this is a set of letter drills, A to Z, and there is the letter I that I will use. But 3/16 will be the pilot hole. I changed things around a little bit here. I put the clamp on the other end, and I am using that Palmgren vise, and I'm going to drill that hole. I already started it, 3/16 all the way through, and I straddle it so that I will come out the bottom without drilling into the vise, and we'll use a little bit of oil, so I'll show just a little bit of that. Now I've been criticized sometimes for not clamping my vise down. So if you're uncomfortable with that, clamp it down. But the reason I like that, I like to float the vise around so that it centers. Sometimes you can force the drill into a different position when you're clamping your vise, but for safety it should be clamped. And all the way through. Now this is the letter I in the same hole all the way through. Break the chips by backing it off. Be sure and hang on to your work real tight as it starts to break through the bottom of the hole, because that's where a drill bit can grab and spin the work around if you're not careful. You can see the hole is all the way through. Again, that's the letter I. I'm going to separate the two pieces, and then the bottom piece here, without the bluing on it, I've marked that hole C for clearance, so I'm going to put that in the vise and drill it 3/8 or 5/16 rather. 5/16. 5/16 is the clearance. I'll do that off camera. I hope this isn't too confusing, but there's the 5/16 clearance hole, and this is the letter I. But what I did here, then I put it back in the drill press and I drilled from this side, and it could be from either side, 5/16. And the reason I did that is that I'm getting ready to tap it now, and I'm going to use this tapered tap, but with a little bit of a clearance like that, it really helps to make your tap go in straight. It's acting as a tap guide. And remember, as far as thread, I think I mentioned this before, that you really don't need any more than this much thread. So I'm not weakening at all by doing that. And now I'll tap the hole using a little tapping fluid there. You absolutely must make sure that you tap this hole straight. If you do not, it will cause a binding in the assembly of the project. It just won't work. So if you're not using my little method here, make sure you sight from both directions and use that tapered tap, and that'll help you tap it straight. And if you're using the milling machine, go ahead and tap it in the milling machine by various methods that I've shown in my other videos. With the tapping completed, I used a 1-inch SAE, that's a fine thread cap screw bolt to hold that. Now I've got them tightened and held together so they're not going to move, and I'll go ahead and drill the other hole. I'm in the process of drilling this other hole back here. Remember, that's a blind hole, and it's a 13/64 diameter, and I'm drilling it 3/16 into the bottom piece, so I've set the depth stop for that. I'm part way through it now. Okay, now it's ready to take out, deburr, and drill the next size hole. Let's have a look. Take the cap screw out. And there's the blind hole. I may have to go just a little deeper with that. That'll be easy enough to do now, but we want this little pilot on the screw to bottom out. Now that'll be alright. No, I'll go in just a little deeper, but I don't want it to come up to the shoulder. This should bottom out. And then I got one more hole to drill here, and this must be drilled out to the letter I, and then it'll be tapped also 5/16 24. I drilled this off camera, letter I again, and then counterbored it with the 5/16, the same as I did here, and I will tap it 5/16 fine off camera. I'll be right back. I went another 30-second deeper with this 13/64 hole. Take your file and deburr both sides of both pieces. I think the holes are done. Let's test them, see if they align properly. As you can see, this knurled screw doesn't come quite down to where I want it to, and that's where I will counterbore this piece just a little bit with 5/16, so a 1/16 inch deep. That'll take care of that. And perfecto. Everything aligns, the holes are tapped straight, parallel in both directions. Now if you didn't follow all those instructions to the T, or you tapped it or drilled a crooked hole, it's going to bind and you're going to be in a little trouble. So let me open that up. I bolted the two pieces together again, and I put some layout die on this side. And the reason for that, if you do it on this side, it's hard to swing this on the belt sander. I want to sand that off, but you may have another method. So I just used a 1/4 inch radius gauge. This is 1/2 inch, so the radius is 1/4 inch. Laid that out, but you certainly can lay it out, swing it with your little dividers as well. So let's go over to the big belt sander. And you see, if you have a belt sander and the table is good and square, we'll just swing it like this until we get down to the layout lines, or until it looks good and that we have a rounded end on it. Something like this. Now that'll take a few moments, so I'm going to do that off camera, and it's going to get hotter than a pistol, so I do have to cool it a couple times. Well, there it is, and it looks pretty good. So that's done, and I can take the bolt out. Now I'm ready to put these angles on, and I'm going to show you several different methods of laying out and 2 different methods of milling it or taking it down. Now if you do not have a milling machine, lay it out like I'm going to show you, and you can saw it and then file it. And that's not the preferred method, but that's the way some of you will have to do it. So in order to lay this out, I'm just going to lay it out on one piece, and I've already got some die on there. And I've got 2 combination squares set here, and it is, we need a line here that's just 1/8 inch from the bottom. Might be better off right like this. One-eighth, and then 1 5/16 in this direction. Like that. And then using a straight edge, I'm just going to connect the 2. It just so happens that that is a 16-degree angle. So if you want to just set your combination square with the protractor head or your protractor, whatever it is that you have, and measure 1/8 inch there, or you can make the other line and just use your protractor to do that. Now let's step over to the to the milling machine, and I'll show you how to set that up by this method. But before I do that, I'm going to make sure you mill that on the correct side. I'm going to lay those together, hold them with a clamp, and then show you how I set it up in the milling machine. This is a method that I always used in the high school when I was teaching, and this can be done on a shaper as well if you got a shaper. But how about that? I'm using a Toolmaker's clamp, and I got those 2 clamped together, and I'll just put them in the vise and snug them ever so lightly. Now, you don't want to put that line right down on the jaws, because then you might run into the jaw. So I always had the boys raise it up a little bit, and in order to do that accurately, and this is a matter of judgment, and because these jaw vices are beveled, I have to use a parallel here, and then I just use a ruler and adjust it up and down until I get that right on the line. And that was difficult for some students to do. Tighten it, remove this, take the clamp off, and it's ready to mill as a pair, and they will both be identical. Now let me show you the method that I'm going to use, and no layout is necessary for it. The other method is to use taper gauges. Well, naturally my set of taper gauges does not hold one that is 16 degrees. There is a 15 degrees, so that could be, we could change that, it wouldn't matter. Nobody's holding us to a dimension here. But what I have done is very quickly, using the protractor, made a gauge. Now a 16 degree gauge, and this is made out of plexiglass, but it could be made out of aluminum or even wood or just about anything that you got laying around. It just doesn't matter because you're only going to use it one time. Now I've rearranged these a little bit so that I've hidden the layout lines just to show you that you do not need the layout lines by this method. Always make sure your vice jaws are clean. Use a brush and then your fingers. And just put the gauge down in there, and you know, this is a chance for some of you to use that sine bar too, although it's rather inconvenient, but this would be a job for a sine bar, but that's working way more accurately than necessary. And then just lay the clamps right on that gauge, which is going to be pretty darn accurate. Tighten it up. Now I'll take the clamp off, and I'm ready to mill. Of course, the reality is you do need a layout line. I just did it the other way to illustrate, so I put it back in with the layout line showing, and I've got it clamped down in the vise. The vise is tightened, that is, so I can take off my Toolmaker's clamp and even pull the taper gauge out, although it doesn't matter at all. Now I'm ready to mill, and I'm going to take it right down to the line. Now make darn sure that you have this second piece in there correctly. So if you can see the blind hole, I'll lift that up. Should not be able to see the blind hole here. If you do, you're milling on the wrong side of this back piece. Alright, let's make some chips. I have a 1/2 inch diameter high-speed steel end mill, and I'm running it at about 1100 RPM with a little oil, and I'm going to mill it to the layout line. This is the final pass. I'll feed a little slower to try to get just a little bit better finish. You can mill in the other direction, the X direction if you want, and just arbitrarily going in the Y axis. They're looking pretty good, if I do say so myself. Now, an optional step is to put it on the belt sander here and swing just a little bit of a radius here. I'm not going to do that, or you could file a little bit, or just break the corner there, whatever you want to do. I'm just going to break it, and I think I will break it on the soften it, whatever word you want to use, right here on the belt sander. This is what it looks like before polishing. You see I did soften those just a little bit. There's just one thing to do yet, and it's a rather aggravating little thing to do, and that is to make this keeper here. I'm going to call that a keeper. Now there's two different ways of doing that, and I didn't cut myself, that's just bluing. And one is to machine it out of solid stock, and that is most laborious. And when I did this one, I started with some 1/2 inch wide flat stock, and don't cut it off the length till you decide how you're going to machine that, and I think I'll try to put that in the drawing what the dimensions are, but you'll have to take the dimensions with a grain of salt, and that's nothing more than a fork that's coming into that groove, something like this. But I'm not going to spend a whole lot of time talking about this method, but you may need to make it by this method, especially if you're in a teaching situation. It looks a little awkward and bulky, and I prefer this type made out of stamped steel, and that's what I'm going to attempt to do by another method, and then it has to be screwed into place with a little hole that's been drilled and tapped, and this particular one is put in with some kind of drive pin, it appears. So let's get started on that. Now let's make the keeper, and I've tried several different ways as just mentioned previously, but my final design is this piece here. Now this material is just sheet metal, cold rolled sheet metal, and in fact it's 16 gauge. And on the bandsaw with a fine tooth blade, I cut a strip that's 1/2 inch wide. Then before doing anything else, well, I guess I should say, first I bent it. Now in order to make a double bend like that, you're not going to be able to do that in a vise. You've got to create a little bending jig or fixture, and this is what I made. And it only took a matter of minutes, but the problem is I had to make several of them to end up with the dimension and the offset that I wanted. Now another way, or another source of material, and this is a little bit thinner, and I played around with this too, was to take a hacksaw blade. Now it has to be a common carbon steel blade, not the brittle high-speed steel ones, and I had to anneal it and then take the teeth off, but that provided a pretty nice stock for that. And I have hundreds of blades in stock, so I didn't mind sacrificing a couple. But I did have to heat them red hot and cool them to anneal them, to make them bendable and cuttable and drillable and machinable and so on. Now here's how I made this homemade jig, and it's just a 1/2 inch square stock, 2 pieces, and I didn't even bother to cut it to length, and just used some remnants that were laying around here. And remember, the 16 gauge steel is a 1/16 inch thick also. So based upon that here, I milled each piece 1/8 of an inch deep and 5/8 long. Now this one's longer because I needed some holes here. Design that yourself, that will align them and keep this from moving when we pinch this in the vise. Just going to put the work in there and pinch it in the vise, and that'll create the bend. This is how I created the bend. My material is clamped in there, and this is an undetermined amount here. I've got about 5/8 of an inch, but I'm going to have to trim that later on anyway. And then I had to use some longer bolts than what you saw a couple minutes ago. I'm just going to put this in the vise and pinch it. Here it is in the vise, and I must confess it is a bit awkward, and I'm sure I could have designed a better one, but when you're making something like this, it's really a prototype. You need to make 2 or 3 of them because I didn't draw this up, but now I've got it clamped in here, and watch the bend. You see it make that double bend? Pinch it good and hard. And there it is. There's really no other good way to make a reverse bend. If you've ever tried it with round stock or rod or wire or anything else, you know what I mean. I'm going to mill that semicircle, and remember that groove was 3/8 diameter, so this is a 3/8 end mill. Now you can do it another way too, by making it longer and drilling a hole. It might be easier to drill a 3/8 hole and then saw it off like that. But I have a 3/8 end mill in here. The work is clamped into the vise, and I've already centered the end mill off camera in the vise there. So what I'm going to do is turn the machine on, come in, touch the work, and then zero out my digital readout and go in half of 3/8, which is 3/16, or 0.187. touched off, and I just zeroed the digital readout. Let's see what it looks like. There it is. Got to take the burrs off now. That's what it looks like so far. And I drilled a 9/64 hole, and that will fit a 632 screw. And next thing I'll do is cut this off the length, but do any filing or fitting that you need to do before you cut it off. That way you got a handle to do anything you want. And we got a pretty good fit, or I got a pretty good fit here, as you can see. Matter of fact, I think I'll locate the hole and drill it and tap it in here before I cut that off. I'll take my own advice on making it easier to handle. You can see that the actual offset here is about 3/32 of an inch. I transferred that hole using a transfer punch. And now taking that off, I will drill that. Let's see, number 36, so I can tap it 632. And the screw isn't very long, so I don't need to have much of a thread, but I like to drill extra deep so I don't have to deal with a blind hole when I'm tapping. A shallow blind hole, I should say. The hole has been drilled and tapped, and I have a screw in there, and I'm checking the fit now and the feel, and there's no bind at all. I still feel I have just a little bit of space right here, but part of that is because the shoulder, right here, the shoulder is not real square on that piece, but I'm not going to go back and do that because that's going to work just fine. Now I'll take it off, and I'm going to cut it off on the black line and around the corners just a little bit, and then that piece is done. A lot of work in that little piece. Let's talk just a little bit about finishing. And I believe these are case hardened, these factory made ones. But notice they didn't even bother to get the milling marks off of that. And there's no brand on this. I don't know what make that is. But this is a piece of new old stock emery cloth. Had it around here forever. This United States Sandpaper Company. I never heard of it. Emery cloth. They actually use the word emery cloth. 2-aught grit. And I'm just going to clean these up in this manner on all 4 sides. Then when I'm done with that, I'm going to take some finer paper and do it a second time. And possibly, this isn't a real bad finish here, but I think I can probably improve it just a little bit in this manner. So I'm going to do a little polishing off camera, and then I'll break all the corners like this too. Soften them, and it makes it look finished. That's about as far as I'm going to go polishing it at this time. Now you can draw file that too. I still got a few machining marks in there I'm not too concerned about, but this can be draw filed, which produces a real nice finish, and or it could be surface ground if you have a surface grinder, or blued, like with gun blue. So there it is, taken to completion, and hopefully some of you out there will try this, and that's what that clip looks like in the end. That was a project in itself. And it may or may not be easier for you to make it in this version with the machined clip. So that's it. Hope you enjoyed the video on this 4-inch Toolmaker's clamp. And of course you want to make a pair of them. And this is Toolmaker saying so long for now.